Hello, Mr. Rose here. I'm here to explain how you are going to check your work from yesterday, the dog nap revisit. So, vector maps, drawing things to scale, is probably pretty difficult. Well, it's not really difficult, it's more tedious. Today, you are going to be able to check to see if you did all of that work correctly. Now, in theory, you could have done it graphically, followed by a mathematical explanation like I introduced yesterday, but this is going to be checking to see did you draw it graphically correctly. So this is not posted just yet, but it'll be posted obviously because you're watching this. You're going to click on the vector addition website, and that is going to bring you to this page. Once you're here, I need you to go back to your Google Classroom, and you need to go to yesterday's assignment, and you need to look at your dog napping assignment. So the dog napping assignment, that gives all of the directions. You were going to recreate this, but now instead of doing it by hand, you can do it on the computer. So I'm just going to look for this first thing. From his house, he goes 100 kilometers east, then he turns and goes 500 kilometers in the direction of 30 degrees north of east. So I go here, and now you're going to notice I am going to need a scale, and I'm not going to tell you what that scale is, but this is all of the room I have to work with. So I'm only going to use the same color vectors, and the reason why I'm going to do that is you see these values up here where they have sum and sum. After I add them all up, I can look for the sum, and you're going to check to see if the sum adds to the same resultant and the same degrees that you got yesterday. So that first vector direction was 100 kilometers due east. So whatever my scale is, I'm going to pretend that it is just on the bottom here. This 10, I'm going to say one box is 1 kilometer. And let's see, W east, so east is going that way. So I'm going to take my vector, I'm going to put it right here because that's where I want to start. And I'm going to say it is 10 kilometers due east. Then the next set of directions were, I then go 500 kilometers, an angle of 30 degrees, 30 degrees north of east. So I go back, I take that same one. I have to go north of east, so I'm going that direction. So if this was my compass going up and down and left and right, it would be right here, right at that 20 line. And I would need 30 degrees. Now notice this 135. Now you're going to need to figure out some math here because 30 degrees is talking about this angle, and this 135 degrees is always reporting from quadrant 1. So this would be 90. All the way up here would be 180. So if I need 30 degrees, I need 180 minus 30, which is like 180, 170, 160, 150 degrees. And then I would need to make it the right size. So it is going to be a little off, you can tell. I don't want you to be frustrated, but we are checking to see a general explanation because of our clicking, right? So that's 144 degrees. The next where it'll click into place is 150.3 degrees. So you need to do your best to get your vectors to be the right size with your scale, and you need to do your best to get the degrees correct. Now that's 150.3. Now, Mr. Rose, how do I get my vector correct if I'm on this angle and I made a scale of, say, 1 box equals 10 kilograms, or sorry, 10 kilograms, excuse me. 1 box equals 10 kilometers. Well, what you're going to do is you're going to first take your vector and put it either straight up and down or straight left and right. Like if I made my vector there, I started 5, I ended at 15. So this is 10 units long. If that fit my scale, I then need to go and put it where it is. And now I need to not adjust the size, but adjust the angle. Now, I'm not going to be able to get it exactly if you notice on this top corner. Again, because of this clicking problem, it may not be exactly 10. Like that would be exactly 10, but if I need to be there, I might not be able to keep it at exactly 10. So you're going to need to do as close as you can to see if your answer is as close as you can possibly get it to what you did in your vector map. I hope this made a little bit of sense. Good luck. And now, last part. Sum. When you're all done, you press the sum. And the sum is the resultant. It's going to go from start to finish. And notice how I have that fit. And no matter what, it's going to change. It changes with my vectors. If I add another blue vector, all of a sudden, the vector got longer. Remember, order doesn't matter with vectors. So in theory, I could do anywhere I want. I would always have the same magnitude and the right direction. All I would need to do is put that at the starting place because the resultant goes from start to finish. Now, if I push the other sum, I don't have anything because this red one represents if I had orange ones out. So only pick the same color vectors. That's all I have for you. Good luck. Again, send any emails we have. I will be collecting the work, like I said, from yesterday. This is just a good check. And are you doing vectors correctly?